Hello and welcome to this video. Today we are going to discuss EFS in detail with respect to performance and security. Before we begin, let me quickly introduce myself. I am Ajit Inamdar. I work as a cloud architect with one of the leading cloud consulting companies in India. I have about 10 years of experience in the IT industry across multiple domains. I am 9x certified AWS professional. Apart from that, I am also recognized as an AWS ambassador and a community builder. Please feel free to connect with me on LinkedIn. The link is mentioned here. So let's see what we are going to cover in this session today. Firstly, we will understand what exactly is Amazon EFS. Then we will move towards key features of EFS. We will then understand how we can optimize Amazon EFS performance. Then we will see security best practices working with Amazon EFS. We will see some AWS services where Amazon EFS can be integrated. And finally, we will have a hands-on demo. So let's see what exactly is Amazon EFS. Amazon Elastic File System or Amazon EFS provides a simple serverless elastic file system for use with AWS cloud services and on-premises resources. It is built to scale on demand to petabytes without disrupting application. It will grow and shrink automatically as you add and remove files. Amazon EFS has a simple web services interface that allows you to create and configure file systems easily and quickly. The service manages all the file storage infrastructure for you so that you don't have to manage the complexity of deploying, patching, and maintaining complex file system configurations. We have learned what is Amazon EFS. Now let's understand the key features of Amazon EFS. Amazon EFS is a fully managed service providing NFS shared service system storage for Linux workloads. With Amazon EFS, it's pretty simple to create and configure file systems. You don't have to worry about managing file servers or storage, updating hardware, configuring software, or performing backups. In barely seconds, you can create a fully managed file system using the AWS console, AWS command line or the CLI or AWS SDK. Amazon EFS is designed for 99.11 of durability and up to 99.4 times 9 of availability. By default, Amazon EFS redundantly stores every file system across multiple availability zones for file systems using standard storage classes. And if you select Amazon EFS one zone storage class, your data is redundantly stored within a single AZ. You can architect your application for failover from one AZ to other AZs in the region for a high level of application availability. EFS replication allows you to replicate your file system data to another AWS region or within the same region in a few clicks without requiring additional infrastructure. AWS Backup is a fully managed backup service that makes it easy to centrally manage and automate backups of your Amazon EFS file systems, removing the need for costly custom solutions and manual processes. Amazon EFS offers standard and one zone storage classes for both frequently accessed and infrequently accessed files. Standard and one zone storage classes are performance optimized to deliver consistently low latencies. The Amazon EFS Standard Infrequent Access and the Amazon EFS One Zone Infrequent Access storage classes are cost optimized for files accessed less frequently. You can start saving on storage costs with EFS Lifecycle Management and with an age of policy that is 7, 14, 30, 60 or 90 days. You can control network access to your file systems using Amazon VPC security group rules and application access to your file systems using AWS IAM policies and Amazon EFS access points. Amazon EFS is designed to provide the throughput, IOPS and low latencies necessary for a variety of workloads. Amazon EFS offers two performance modes, that is general purpose and max IO. General purpose provides sub-millisecond read latency and low single-digit millisecond write latency for random or sequential IO patterns. Max IO scales to higher levels of aggregate throughput and operations per second, which is ideal for highly parallelized application that can scale out to thousands of EC2 instances. Amazon EFS offers two throughput modes which determines the overall throughput a file system can achieve, that is bursting and provisioned. With bursting throughput mode, throughput scales with the size of file system, dynamically bursting as needed to support spiky nature of many file system based workloads. Provision throughput mode is designed to support applications that require higher dedicated throughput than the default bursting mode, and it can be configured independently of the amount of data stored in the file system. We will talk about the same in the slide later. With Amazon EFS, storage capacity is elastic, growing and shrinking automatically as you add and remove files to dynamically provide storage capacity to your applications as needed. Amazon EFS is designed to be highly scalable both in storage capacity and throughput performance, growing to petabyte scale and allowing massively parallel access from EC2 instances. With Amazon EFS, throughput and IOPS scale as your file system grows, while file operations are delivered with consistent low latencies. Amazon EFS provides a complete encryption solution to secure both your stored data as well as data in flight. Data at rest is transparently encrypted using encryption keys managed by the AWS Key Management Service, that is KMS. Encryption of data in transit uses industry standard transport layer security to secure network traffic without the need to modify your applications. Amazon EFS is integrated with AWS containers and serverless compute services that require shared storage for latency sensitive and IOPS heavy workloads at any scale. So we have seen key features of Amazon EFS. Now let's dive deep into EFS performance. Amazon EFS uses two types of storage classes, that is EFS Standard and EFS One Zone. EFS Standard and EFS Standard Infrequent Access Storage classes are regional storage classes that are designed to provide continuous availability to data even when one or more availability zones in the AWS region are unavailable. They offer the highest level of availability and durability by storing the file system data and the metadata redundantly across multiple geographical separated availability zones within a region. EFS One Zone and EFS One Zone IA storage classes are designed to provide continuous availability to data within a single availability zone. The EFS One Zone storage classes store file system data and metadata redundantly within a single availability zone in an AWS region. Because they store data in a single availability zone, although it might be a cheaper option, data that is stored in these storage classes must be lost in an event of disaster or other fault that affects all copies of the data within the availability zone, or in the event of availability zone destruction. There are two types of performance mode, that is general purpose mode and the max IO mode. General purpose mode supports up to 35,000 IOPS and has the lowest per operation latency. File systems with EFS One Zone storage classes always use general purpose performance mode. For the systems with EFS standard storage classes, you can use either the default general purpose performance mode or the max IO performance mode. Max IO mode supports 5 lakhs IOPS and has higher per operation latencies when compared to the general purpose mode. You can set the performance mode when you create a file system and you can change it after it is created. It is recommended to use general purpose performance mode for vast majority of applications. If you are not sure which performance mode to choose the general purpose performance mode to help ensure that your workload stays within the IOPS limit available to the file systems using the general purpose mode. A file system throughput mode determines the throughput available to your file system. Amazon EFS offers two throughput modes, bursting throughput and provisioned throughput. Bursting throughput mode is the default Amazon EFS throughput mode. It is a good fit for traditional applications that have a bursty throughput pattern. When throughput is low, bursting throughput mode uses burst buckets to save burst credits. When throughput is higher, it uses burst credits. A file system's throughput mode determines the throughput available to your system. Amazon EFS offers two throughput modes, bursting throughput and provision throughput. Bursting throughput mode is the default Amazon EFS throughput mode. It is a good fit for traditional applications that have a bursty throughput pattern. When throughput is low, bursting throughput mode uses burst buckets to save burst credits. When throughput is higher, it uses burst credits. For applications that have a relatively constant throughput, we recommend provision throughput mode. In provision throughput mode, you specify a level of throughput that the file system can drive independent of the file system size or the burst credit balance. We just learned all the EFS performance parameters. Now let's understand few security best practices working with EFS. Amazon EFS supports two forms of encryption for file systems: encryption of data in transit and encryption at rest. You can enable encryption of data at rest while creating the Amazon EFS file system. You can enable encryption of data in transit when you mount the file system. We will see the same in action during our demo. Access to Amazon EFS requires credentials that AWS can use to authenticate your requests. Those credentials must have permissions to access AWS resources such as Amazon EFS file system or an Amazon EC2 instance. IAM helps to secure your EFS resources by controlling who can access them. You can control access by NFS clients to Amazon EFS file systems using network level security and EFS file system policies. You can use the network layer security mechanisms available with Amazon EC2 such as VPC security group rules and network ACLs. You can also use AWS IAM to control your NFS access with an EFS file system policy and identity based policies. Monitoring is an important part of maintaining the reliability, availability and performance of the Amazon EFS and your AWS solutions. You should select monitoring data from all parts of the AWS solution so that you can easily debug a multi-point failure if one occurs. Amazon provides several tools for monitoring your Amazon EFS resources and responding to potential incidents. To add permissions to users, groups and roles, it is easier to use AWS managed policies than to write policies yourselves. It takes time and expertise to create IAM customer managed policies that provide your team with only the permissions they needed. These policies cover common use cases and are available in your AWS account. Third-party auditors assess the security and compliance of Amazon Elastic file system as a part of multiple AWS compliance programs. The AWS global infrastructure is built around AWS regions and availability zones. AWS region provide multiple physically separated and isolated availability zones which are connected with low latency, high throughput and highly redundant networking. With availability zones, you can design and operate applications and databases that automatically fail over between zones without interruption. Availability zones are more highly available, fault tolerant and scalable than traditional single or multi-data center infrastructures. Network level isolation can be provided to Amazon Elastic file system using resource-based access policies, which can include restriction based on the source IP address or specific VPCs or specific VPC endpoints. Let's see how EFS works with different AWS services. This is how an example EFS workflow would look like. Firstly, we will create Amazon EFS using EC2 Wizard, EFS console, CLI or the API. We will select the various parameters like performance and throughput modes. We will then mount the file system on EC2 instance, containers, Lambda functions or on-premises based on our requirement. After the system is mounted, we will test and optimize performance for workloads. We can leverage tools like Data Sync or SFTP using AWS Transfer Family and move the data to Amazon EFS. After the movement of data is complete, we can share the data, then optimize cost with EFS lifecycle management and protect the same using backup and EFS replication. These are some of the example services where you can integrate EFS with. These are EC2, ECS, EKS, Fargate, SageMaker and Lambda. We have seen a lot of theory around Amazon EFS performance and security. Now let's head on to the AWS console and see everything in action. So for the demo, we have logged into AWS console. In the search box on the top, let's type EFS. This is the EFS landing page. On the left hand side, we will see some options. On the right hand side, we will see option to create a file system and some pricing information. So let's click on the create file system. Enter a name of your choice. I'll give EFS Demo. Here you see two options to select availability and durability, that is regional and one zone. We have already talked about the same in the slides. If you select one zone, you have to select in which AZ you want your EFS to be deployed. I'll choose regional. Here we have two buttons, customize and create. If I click create, it will choose all the default configuration and create the EFS. We will select the customize button. Once we click on the customize button, on the left hand side, we will see 4 steps, that is file system settings, network access, file system policy, and review and create. We have already selected regional for availability and durability. Under the automatic backup, the enable automatic backup is checked by default. It is always recommended to have backups enabled. Lifecycle management is basically to save on costs. If you have data which is accessed infrequently, we can set up a lifecycle policy here based on our requirement. Under transition to IA, we are keeping it as 30 days since last access, as we want to move all the data to infrequent access if not accessed for 30 days. In the transition out of IA, we will keep on the first access, so all the objects which are accessed will move back again to the standard storage. In the performance mode section, we have couple of options again, general purpose and max IO. General purpose mode supports up to 35,000 IOPS and has the lowest per operation latency. Max IO mode supports 5 lakh plus IOPS and has higher per operation latencies when compared to general purpose mode. I'll select general purpose mode for this exercise. Moving to throughput mode, we have two options, bursting and provisioned. Bursting throughput mode is the default Amazon EFS throughput mode. It is a good fit for traditional applications that have a bursty throughput pattern. For applications that have a relatively constant throughput, we recommend provision throughput mode. If we select provision mode, we have to pass a provision throughput. For example, I am passing 20 MIBs. Will give you max read throughput of 60 MIB. For now, I will select bursting mode. In encryption, the enable encryption is enabled by default. If we don't customize the encryption settings, AWS uses the default EFS key. For this demo, I have already created a KMS key, so I will select the same. In the key aliases, you can see EFS-demo-key. Under the tags, I am passing a tag created by Ajit and choose next. Under step number 2, we have the network access. In VPC, we have only one VPC, so it is detected by default. Under the mount targets, we have one in each availability zone. The security group selected is the default SG. As a best practice, we should have a custom security group. So let's create a new security group from the EC2 console. Click on create security group. I am entering security group name as EFS-demo-SG. and keeping the same for description. For now, I am not adding any inbound rules. I'll add the same at a later stage. The new security group will not reflect in the drop-down. So let's go back to the previous step and click on Next. Now let's add mount targets in each availability zone with the new custom security group. On step number 2, we have file system policy options. The first one is to prevent root access by default. Let's see what happens after enabling that. The second option is enforce read-only access. After only selecting that, elastic file system client write goes away. The third option is prevent anonymous access. This is to restrict access to your EFS. It will remove the mount permissions. The last one is to enforce in-transit encryption for all clients. This will reject all requests which doesn't have a secure transport flag as true. If you want to provide any additional permissions, you can provide here by adding the ARN and appropriate permissions. For this demo, I am selecting the last option to enforce encryption. You can select all the options that are applicable to your use case. Once done, I'll click on Next. Let's quickly verify all the options that we need. Name, performance mode, throughput mode, encryption, KMS ID, lifecycle management, automated backups, and availability zone. Some of the fields here are not editable after they are created. They are performance mode, encryption, KMS ID, and availability zone. Tags are fine. Network access policy is fine. Now let's hit create. Now here we see that the file system is being created and it's available. Let's get into EFS and quickly verify whether all parameters are as expected. Under Tags tab, we can see the tags we provided and an additional tag for backup. File system policy is what we selected. We don't have any access points. Under network, we can see mount targets are being created in each AZ. If you want, we can set up replication of EFS under the replication tab. Since the mount target is still in creating state, let's make changes to our security groups. I've already created couple of EC2 instances for testing and have attached a common custom SG for both of them. Let's select one instance and go to the security tab. Select the security group and edit inbound rules. Add a new rule for NFS with source as the security group of our EFS. Similarly, we have to make changes in our EFS security group as well. Let's go to that group, go to inbound rules, edit inbound rules, add a rule for NFS, and source would be SG of your EC2 instances. Now let's go to the EFS console and check whether our mount points are available. We can see that all three mounts are up. Let's go back to our EC2 console and connect both the instances one by one in our browser window. In the first instance, let's elevate our permissions and install the Amazon EFS utils. Let's do the same in the second EC2 instance as well. Now that our utils have been installed, let's create an EFS directory. Now go to the EFS console, click on attach button, copy the mount helper command. In the command, we can see TLS for our in-transit security. Let's run the command which we copied. We can see that EFS has been mounted successfully. Let's follow the same steps on the second EC2 instance, that is creation of EFS folder and mounting the EFS. To test our setup, let's get into the EFS folder of our first EC2 instance. Let's create a file using the touch command. Let's quickly check whether the file is created. Go to the second instance, get into the EFS folder and check the files. You can see the file previously created is visible here as well. Let's create another file from here and check in the first instance. Now we can see both the files are as required. So this completes our demo. Thanks for watching till the end. We have planned more such videos in the future, so please stay tuned.